Terminal velocity calculations. This is the problem statement. There are oil droplets. The diameter of these droplets is 2 millimeter, and these are in the air. The temperature of the air and the pressure of the air is given. The density of the oil is given. So these oil droplets are settling in the air. We have to calculate the terminal settling velocity of these particles, and viscosity of the air medium at the given conditions is given, and the drag coefficient CD is given by the expression shown on the screen. Theory. We already know that there are three regions of flow. The first flow is laminar flow when the particle Reynolds number is less than 1. In this flow conditions, the drag coefficient is given by CD is equal to 24 divided by the particle Reynolds number. If the flow is laminar, the terminal velocity will be calculated by the formula shown in the figure, where Vt is the terminal velocity, dP is the particle diameter, rho p is the density of the particle, and rho is the density of the medium in which the particle is settling, and mu is the viscosity of the medium. Now the turbulent flow, when the particle Reynolds number is greater than 1000, the drag coefficient under these conditions is given by CD is equal to 0.44. It is always constant. Now the third region is the intermediate region, that is between laminar flow and the turbulent flow. Under these conditions, the drag coefficient CD is given by many correlations. One of the correlations used is Shiller and Norman correlation, and the formula is given on the screen, where CD is drag coefficient and REP is particle Reynolds number. So this way you can calculate the drag coefficient when your flow is intermediate. Now the algorithm for calculating terminal velocity, and in our problem we have been given intermediate region, so we will use the CD for the intermediate region. These are the steps. First step is, because you don't know the terminal velocity, so in these type of calculations you need to assume some value of the terminal velocity. And the second step is, at the assumed velocity calculate particle Reynolds number. And then in step 3, with this calculated Reynolds number, you will calculate the drag coefficient. The fourth step is to calculate the terminal velocity with the formula shown on the screen. All the values are given in the problem. That is the density of the particle, density of the medium, diameter of the particle, and CD you have just calculated. Step 5. Repeat the same procedure. I mean, from step 1 to step 4 you have to repeat until the difference between the new terminal velocity and the old terminal velocity is very small. That is, when it is less than the tolerance value that you have set for the problem. Now we come to the important part, that is the Scilab codes. First we will define a function to get the gas density. It is not important to define a separate function, but you can calculate the gas velocity in line. But here we have defined a function. The formula to calculate the gas density is given inside the function. Here are the constants that are given for the problem: G, molecular weight, pressure, temperature, density of the particle, diameter of the particle, viscosity of the medium, and then we calculate the viscosity of gas with the help of the formula that we had defined earlier. Assume some initial value of the terminal velocity. We have assumed 0.03 meter per second. This is the loop, that is the iteration that we are doing. We are using while loop here, and we are running an infinite while loop, and in each iteration we are calculating particle Reynolds number, and after then we are calculating CD, and then we are calculating the new terminal velocity, and after then we are comparing it with the old terminal velocity. And when the difference is less than 1 into 10 to the minus 6, that is our tolerance, then we break the loop. After running the codes, the result we have got terminal velocity is 6.53 meter per second.